right, so as he said, I'm Nate Bittinger. I'm with Docker. I head up the security supply chain space. And so it's no surprise that I'm going to talk to you a little bit about security as it relates to AI and the things that we might be experiencing in this world today. Figure out this clicker. So I'm going to talk a little bit about the agentic flow for a minute, and I realize we're not in the agentic track, but I want to use this as a baseline for us. So when we think about the agentic workflow, we generally position it into three major phases, and this can be applied to any AI project, really. First, we identify a problem. We construct some kind of agent or AI space to solve that problem. That could be your personal assistant digging through emails. It could be attending to calendar invites for you. Maybe it's a senior developer who's reviewing PRs on behalf of the team, or it could be anything that observes all your shared documents and provides you with summaries of those. Whatever it is, it's some kind of AI that has a specific task that it's setting out to accomplish. Once we've defined what our problem space is, we've started to look at what tools we want to give it. We now need to equip it with those tools. In a lot of cases, this used to be CLIs, APIs, or custom authentication packages or things of that sort, and we would arm it with tools to go interface with other systems. We'll come back to that in just a minute. The last thing we do is we then deploy and instruct those agents, those AI tools that we've built. In a lot of cases, they work ceasingly. I mean, that's the point of AI. It can work without an interface. It can work tirelessly, unlike us who need to take breaks. And usually, they'll work flawlessly. Sometimes, just sometimes though, they might encounter something unexpected, and they go in rogue directions that we weren't expecting. So what might have happened here? What are the things that are going on in our AI that cause it to have security flaws and cause it to go out beyond its boundaries? Let's come back to this equip step for a minute. As I mentioned, in previous iterations of AI, we would give it direct access to CLI tooling, to APIs. We'd give it direct instruction on how to go access a piece of data. Maybe it's your Jira server. Maybe it's your GitHub PR flow. Maybe it's your issues centered somewhere else. Nowadays, when we talk about that, we tend to be talking about MCP tools, MCP servers, and MCP services that are available. If you're not familiar, MCP is the Model Context Protocol that Anthropic has kind of defined. So in this way, what we're seeing is in about a year, the MCP protocol has gone from a niche spec from Anthropic to this massive powerhouse that's really gaining global traction. And it's showing up in everything from your IDE, so VS Code, Claude Code on your desktop, or any of these others. And our MCP tools that go with that are being integrated into all of your chat apps, to all of your LLMs, and everywhere else we have it. I like the little tongue-in-cheek here. Everything seems to have an MCP server nowadays. So I want to buy this pen. Sure, you should buy this one. It's got an MCP server attached. I think, though, as we see this rapid adoption and we see the escape velocity of a tool like MCP or this protocol, we start to see a new set of challenges, specifically a bunch of security challenges that go with this. And what I'm here to talk about is how to run your MCP a little more securely and how to scale it within an enterprise setting. So again, despite its rapid popularity growth and the adoption by everybody industry-wide, and I do mean everybody, there are a lot of people out there who are adopting MCP, who are putting it into all of their products, interfacing tools with it and whatnot, we really see it as still playing catch-up with the industry, and specifically as it relates to the enterprise context. What we're seeing from the developer side is that there's three main areas, three main challenges that you're going through. The first is discovery of tools and which tools you can trust is very fragmented. There are GitHub repos, there are repositories all over the place, there are registries out there in all kinds of different contexts. Everybody is building out these MCP server lists. Come grab ours, we've got the latest and greatest. We've got tools that are available to you, but figuring out which of those are official, where's the official GitHub MCP server? Is it the one that I see from GitHub? Is it the one that was forked and published by somebody else? That's really difficult today. And you definitely don't want to be running unvetted servers on your local machine, definitely not in your production environments, and your IT DevOps, DevSecOps, whatever you might have in your organization doesn't want you doing that as well. So running things that you find off the internet, running things that your developers might find on Stack Overflow or Reddit is a real problem for everybody, and it puts your agents that you're deploying, puts your other LLM models that are out there, it puts your applications and your general posture of security for the org at risk. The second is installation. This is a terrible mess right now for the developer. And again, I'm going to focus on the developer for a moment. We'll come back to the enterprise in a minute. Your developers are going to go clone a bunch of repos. They're going to generally use a node-based or a Python-based server software, so NPX, UVX, and they're going to run the commands that they found online to install that MCP server. What's going to happen with that? In the case of Node, we're going to download hundreds, thousands in some cases, of packages. Who knows what's included? You don't know. Your IT doesn't know. Your enterprise software folks that are your watchdogs don't have a clue what's going on in that. Every one of those also uses a different setup method. So even if they were all Node and they were all concentrated in this, each one is going to have different configuration packages that go with it. So we've got YAML files, we've got other ways of passing things around. And then when you add on top of that, VS Code, Cursor, Claude, et cetera, for clients that want to talk to these things, those all have their own forms of files and syntax to pass around authentication or different types of configuration. The result is this massive configuration drift across a company, across a team. One developer's machine no longer looks like another developer's machine. We both want the same tool, the same MCP. We want our agents and our LLMs to have access to those tools, but now my configuration is different than yours. And the last is a weak security posture. A lot of these, as I mentioned, are launched with NPX, UVX, et cetera, and that puts this unverified code into your system. You really don't know what package load is coming with it, the vulnerabilities that exist there. We just this summer saw the upstream node injection of a malicious package affected a huge amount of the industry. You're now exposing node packages to your local system, your local file system, and that is not something that you really want to be doing. It leads to a lot of configuration issues and the potential exposure of your data out there on the web. When we think about the general space, it's more than just these issues that our developers encounter with figuring out which are the trusted sources and how to put them on a machine. We're also seeing a whole new set and a new class of threats designed to exploit how MCP works. If you haven't heard of Simon Willison, I encourage you to go look up his lethal trifecta. He's the individual who coined the term prompt injection, and he's got great articles about prompt injection, jailbreaking in MCPs, things of this sort. Great resource to look at. But what we're seeing is there's some major things here. Prompt injection, which is the hostile content that might instruct your model to exfiltrate data. It might give it different instruction sets than you were expecting it to, or it might call out to dangerous tools. Tool poisoning, this one's really interesting. This is where you get hidden instructions. Maybe we've asked our AI to go crawl some other source. That source now has embedded instructions, and they might not be visible to you or I, but they're machine readable by the AI, and now it interprets those as new instructions, and it circumvents the user intent of what I asked my agent to do. The next one, rug pulls. This is actually my favorite term. This is when I authorize my MCP tool to go do a thing. It says it's going to do A, B, and C, and I authorize it to do that. Tomorrow, though, there's an update upstream. When I run that, tomorrow, it's now doing something completely different. So what I authorized yesterday is no longer the results I'm getting today. This is a very unique one. We call that the MCP rug pull. And then MCP shadowing, similar to tool poisoning, this is the idea that you get an injection of malicious intent, alters the agent's behavior, or even starts making calls to non-trusted sources and so on. So these are new attack surfaces, novel attack surfaces, and things that our traditional security models really don't address. This is not something that Docker is thinking of just in a vacuum. These are big headlines that hit throughout this year. Every month, every week, we're seeing new attacks that are out there. There is a lot of real-world examples of these MCP challenges. Again, it's a great tool, very useful, but it comes with some security risks associated. And I do see people taking pictures. They told me that they'll be sharing our slides after the conference as well, so you'll get all this reference material. So why is this so difficult? Why in the MCP space is this such a problem for us? I think first and foremost, I see it as an issue because MCP and AI in general, all these agentic systems and whatnot, they are dynamic, they are non-deterministic, and they're really unpredictable when it gets down to it. The same prompt in this minute might yield different results than a prompt I issue in another minute. These tools are designed to interpret your intent, to service what you've asked it to do, et cetera, but they aren't repeatable in that same way as other tooling we have. The second thing is that LLMs really aren't good at separating content and user intent from instruction. As I mentioned a minute ago, we have some of these new attack vectors that will actually scrape and read content, interpret it as instructions, and override the user intent of whatever the agent or the LLM was meant to do. And for every new tool, or as I like to frame them, new friend that your AI is making, you've connected instantly to who knows how many other products. You don't know what's under the hood of the AI API that your service is now available to call. You don't know what other data sources it can interface with. Perhaps there's actually a downstream AI interpreting your AI's instruction set. And there's just this exponential expansion of what an agent can do and what an attacker can exploit. So with that, it's really no wonder that our CISOs of the world are very worried. This is a set of data that comes from a BCG survey, and it finds that the top concern for security leaders is AI-powered cyber attacks. So if we zoom out, we were focused a lot on the developer, on the tool itself. When we start thinking about these things at an enterprise scale, these aren't linear. They don't just add up, right? They multiply. All these challenges we have become a very big burden for your organization. What might feel like a developer frustration at first at the individual level really turns into a daunting integration effort and poses systemic operational risk for your organization. We talked through a number of these things. I'm just going to give you a couple examples of where this expands from the developer to the enterprise. So on the installation side, what might have just been cloning a repo or wrangling those Python and Node dependencies for one developer quickly balloons out of control into configuration drift, as I mentioned, across dozens of teams, hundreds of humans, and the organization at large. Each team is now maintaining a slightly different setup, and the result is that your reliability goes out the window. There's security practices that might already feel brittle to local testing, just collapse in the face of unverified code or plain text environment variables being passed around. API keys and database passwords have to be served to these things in some form or fashion, as we mentioned, and all of a sudden we've got this weak security that's going on. So how do we think about scaling agents and their MCP friends for the enterprise? I think the answer might be familiar, and what we're seeing is a lot of the industry is already saying it, that agents are the new microservices, and we can take a page from the cloud-native applications and how we scale those today. Our cloud-native solutions rely heavily on composability, modular tooling, and scalable infrastructure. And just like those microservices need isolation boundaries and they need governance in order to succeed, so do our agents, so do our LLMs, and so does anything we want to deploy that has a generative bent to it. So here at Docker, we see 3 pillars for scaling these things for the enterprise. We see that first, you have to have a base of trusted content. As I mentioned, the fragmented discovery problem is a big deal. So you want to provide a secure, vetted foundation right from the beginning. You want to make sure that you're getting your MCP tools, your MCP servers from a trusted source. On top of that, you need some kind of secure runtime. You need clear isolation boundaries for these areas of running. And finally, you need a really strong governance, and you need enterprise controls to ensure safe and compliant operations at scale. Now, this one might be a little bit predictable. I do work for Docker, but we see containers as that vehicle that's going to help us secure the agentic world. You might be saying to yourself, why containers? Why is this so relevant to our microservice, our Kubernetes deployments, and everything else, and also now going to include AI agents? Well, I think it's because containers largely abstract away the complexity. They make it easy to build, to package, and to run software across any different type of environments. Makes it easy to pass my configuration from one machine, one tool area to another. And they also provide the way to deliver that trusted content. So I mentioned we can package these. We also have common protocols for delivering containers from one system to another. And then we can enforce the security of the runtime. And all of this applies to our LLMs, to our agents, as well as to those microservices out there. We've got data to back this up. It's not just Docker saying containers are a good thing for agents. We did a study with Pantera on the state of agentic AI. And we had over 800 survey participants. And of those, 94% reported they're already using containers to build their agents, to build their AI workforces, and so on and so forth. This is a big deal. And to us, the conclusion is pretty clear. Containers are the thing that will create isolation boundaries. They're the controls for all of our cloud services, and now they're foundational to the agentic flow and to AI in general. So let's dig into the pillars just a little bit here. We'll talk about trusted content, right? So first, we need to look for containerized MCP servers somewhere. Your teams need to be able to know that they're getting something that they can trust. They don't want to clone these random repos. So you need a verified source. At Docker, this is not a sales pitch. This is just us saying this is how we're solving the problem. At Docker, we have a hub that has all of these different types of images in it. Those are containerized MCP servers. So again, we get the isolation boundaries of what can this talk to, what network accesses does it have, and what can it reach out to on other behalf. And if you need an even more secure system, we also have hardened image variants of these. So you can strip out things like root access, package managers, different tooling that might actually expose you to more risk. If you're not using Claude Code or similar tools on the command line today, and you start using it tomorrow, one thing it might ask you for is file system access. If you were to give that on your local machine, that is a really bad thing to do. It can now modify your system files. You want it to have a better context boundary than that. So putting your MCP server into a container makes sense here. The second thing is about the secure runtimes. So when we talk about containers, we're really talking about boundaries for these MCP tools and for the servers that they're running. We think that every one of these should be in its own container. So we have these hubs that offer trusted content from partners, from vendors, from the community. Now what's inside of those needs to have the appropriate boundaries drawn. What we also see is that there's this huge need to manage secrets in the right way, to pass configuration files in and so on. So we've got a set of tools that are available that offer you to share credentials with only authorized MCP servers, and only when asked for, authorized and required. And I think that's a big thing here. kind of minimizes your risk for accidental exposure and leakage. And the last thing is, we believe that there is a layer that's required between your MCP servers and the outside boundaries that you're looking at. So we've introduced a gateway, an MCP gateway, into our tooling that allows you to run all of these MCP tools internally. And it acts as a centralized enforcement layer, making it possible to detect and to block threats like the tool poisoning that I mentioned before that can spread. We don't think of this just as the way to containerize the MCP tools that we're equipping our agents and our workflows with. We also think this is the right way to approach your agent development, your agentic deployments. And what we're starting to expand into are sandboxes for added protection. So you can think of this in your local context where I've got a local developer piloting some AI flow that we need to deploy out to production. I want that local developer to put everything they have in a sandbox. I want to containerize that, bundle it up, share it with staging, integration, whatever test environments I might have. And I want DevSecOps to look at this thing before it can get out to production. We see this as a way to ensure those strict boundaries of what it can touch. I mentioned the file system access. The second thing is we think that for AI-driven content like scripts that you might ask it to write, code it might generate on your behalf, this is a safe way for it to execute that without outside access to other things. And as with all other containers that we already have in industry, and they are everywhere, we have fine-grained control over all the resources it can have access to and the network boundaries that it can get. The last pillar that I mentioned is governance and enterprise controls. So as you adopt multiple AI models, you integrate a number of MCP tools, you're building new agents, you're deploying new LLMs, all these things, you need to maintain consistency, security, and observability across all of these, just like any other system we would deploy. We see that a unified management model is something that's required here. You need tools that your teams can use to orchestrate agent workflows that don't have all the fragmented control planes of it works on my machine and here's my configuration, just go use that. That's, again, a potential for a lot of leakage. The second is centralized auth and access control. So you already have systems in your IT teams in your enterprises today. You need organizations need the ability to enforce role-based security, role-based permissions, leverage your current data governance tooling, and ensure that only authorized agents or users can access the sensitive tooling, the data that's in your environments, et cetera. And last, it's all about observability. What we've done to put gateways and these controls on top also ensures that you have enforcement at scale. And so when you're looking at tooling to do these kind of things, you want to be able to have all of the observability that we expect from other systems. You need governance to detect the issues. You need some way to meet your compliance requirements. And you have to keep your agent behavior aligned with all of your enterprise policies, no matter how large your context or your deployment gets. So quick summary here. We do see, Docker sees MCP as useful and powerful. This is an amazing tool. It is something that if you're not already using, you should be using. We've got it going everywhere inside of Docker right now. We've got teams that are working, experimenting, innovating with it. But what we also see is that it's not enterprise ready out of the box. The second thing is trusted content is a critical component. This is one of those three pillars I just talked about. Secure runtimes are a must-have. Strong governance and enterprise controls apply here just like they do to everything else you deploy in your teams and your systems. And we view containerization as a proven way to regain control. So I'll move over and happily answer a couple questions. If we do, I think we've got just a couple minutes here.
Yes, thanks, Nate. Any questions for Nate? Yes, there is one. Sorry, don't take a picture of me.
Thank Thank you very much for your talk. And yes, this is a very much needed solution regarding how OpenMCP is. Did you do any work on the A2A side as well?
I'm sorry, I can't.
Did you do any work on the A2A side as well, agent to agent, in addition to MCP?
Yeah, that's a great question. So what are we doing to solve agent-to-agent communication and all of the different types of orchestration of agents that you might see in the world? We don't currently have a solution that offers something specific to that, but we do see the boundaries being about the same as what I've just discussed now. So as we think about orchestrated workflows, and you think about one agent controlling an army of other agents, what you're looking for is each agent to have a singular task. You're looking for it to have access to only the right data from trusted sources, verified sources, and governance in tow for each. So by containerizing each of your agents in the way that we were just talking about, you end up as a byproduct with some of that intact already. And then if you give each access to only the appropriate MCP tools, then we think that that's a way to solve that problem.
Yeah, thank you for all this work. A eye-catching bullet point you had on a previous slide was that MCP is popular but not enterprise ready. What would the expected path be for people who are already using MCP in production level, enterprise ready products, who have live audiences, customer bases? How do they retrofit containerization into their products? Is there a path forward that Docker Professional Services offers, or I don't know what you want to plug there?
This is not a plant, I promise you, although it's a great question. So yes, there's always a path forward, right? In the early days of microservices, we saw a lot of cowboy coding happening. We saw things kind of get out there before we had full observability of systems. We saw AWS, Google, and others kind of struggle to catch up with the scaling problems of some of that. We're seeing the same thing today. There's a migration path, absolutely, to take what you've done, to come back to the drawing board with certain aspects of it, look at the containerization of it, and most of the folks in this room probably have Docker embedded in their systems somewhere. So it's a matter of plugging it into your CI pipelines, hooking up your agentic tooling, your AIs, your LLMs, and putting it into those containers and deploying it out. Do we have professional services that can help? We absolutely love to consult with our customers on all of this. Absolutely. It's not a plug, but we are here to help, absolutely.
Thanks again, Nate. Thank you very much. Please, another round of applause.